What is constructive interference?
Complete destruction of two waves.
Say that again, Joshua?
Complete destruction.
No, constructive. Constructive, yeah? Yeah, constructive interference is when two waves add, or really combine together algebraically, no, let's not make it complicated. Constructive interference is when two waves add or combine together to form a new wave which has a bigger amplitude. Usually, the two waves add together to form a bigger wave. And then destructive interference is when the two waves combine together to form a smaller wave. What's that? They could, yeah.
Do they combine algebraically?
They do combine algebraically. Part 2, what coherent sources? Coherent sources? Yeah, coherent sources. That is two waves. Yes, of what? Of the same frequency. And what else? Yeah, okay. Yeah, two waves of the same frequency that are in phase. And what does in phase mean? Peak with peak, trough with trough. Not necessarily the same amplitude, although usually it is because they're coming from the same source. But I think for the definition, it doesn't have to be the same amplitude, it just so happens that it usually is. So if you want, you can add in here, usually of the same amplitude. But not always.
And the only two waves, how would I say waves?
I suppose it's two or more waves, yeah, fine. Okay, can I go on to the B part? So in part B, you have a wave of wavelength 628.3 nanometers. Then it hits the slits, which has a distance of 0.125 nanometers. And there's a screen, yes, in the formula book it uses S, but I usually use D in class. But I suppose, okay, if we want to stick with the formula book, we'll call it S. Huh?
No, it was a different S.
Yeah. Anyways, we all know what it is. It's the distance between the slits, whatever letter it is. And then what happens is this will go on the screen to make a dot here, n equals 0, a dot here, n equals 1, n equals 1, a dot here, n equals 2, n equals 2. Okay, and what's the question? What is the distance from the center? Yeah, so they want to know what is the distance to the fourth fringe. Okay, so we can use the formula n lambda equals d sine theta, but we're not using d at the moment, we're using the letter s. So if you want, that's n lambda equals s sine theta. So if I just draw my triangle, we want this distance here. So let me just call that P. So we have this distance we know, 1.25. This angle we don't know. The n we do know. We know that the n is 4. And we know the lambda here. And we know the s here. So I think what I'll do is I'll just get this theta. Sine theta equals n lambda over s, which equals 4 times 628.3 times 10 to the minus 9 all over 0.125 times 10 to the minus 9 equals, alright, let's calculate that.
Minus 9 are cancelled.
Yeah, the minus 9's cancel, which is nice. 628.3 divided by 0.125. Which is 2.01 10 to the 4. What?
That's impossible.
Yes, I know it's impossible. That's why I said what. Did I type something in here wrong?
No, you're dividing by a small number. That's logical.
Sorry, do I have my formula backwards? Is it...
4 by 628.3. You didn't put minus 2.
What's that? It's millimeters. Oh, thank you. This is millimeters, not nanometers. So that's a 6 there. That's better. So my answer is not right here. Times 10 to the power of minus 9, and then times 10 to the power of minus 3. I wrote 6, sorry, millimeters. Alright, that comes in at... Oh, that's better. 0.0201. 0.0201. Great, so can you just do, we can just do a sine inverse here to get the angle. Whoops. Which is, now this is in radians, which is fine, I'll leave it in radians. 0.0201 radians. Okay, so if you go back to this triangle, you have tan theta equals P over 1.25, so P equals 1.25 tan theta.
What is P?
The distance here I'm looking for. I didn't want to call it x. So 1.25 times tan 0.0201 radians. Um, 2.5 centimeters. .5 centimeters? Did you get the same number? 0.025? What? What did you get, Joshua? Eli, did you get this answer? Huh? I didn't finish.
0.025.
Yeah.
But why didn't we use just one formula?
No, I was just going to say, we can also use the other formula as well, which I want to do it that way too, to see if we get the same answer.
Yeah, sure.
Yep. Did it work out the same?
0.025.
Perfect. Well, I'm going to use it. So the other formula you have, I'll write it down here. Lambda equals xs over d, where x is the fringe, s is the slit, and the d is the distance to the wall. So in my example here, N0, N1, N2, N3, N4. Please be careful. The x is the distance between each of the dots. So you have x, 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 and x. So when you get your answer for x, you have to multiply it by 4. So x equals lambda d over s. So x equals 628.3 times 10 to the minus 9 times 1.25 all over 0.125 times 10 to the minus 3. So if I type that all in, 628.3 times 10 to the power of minus 9 times 1.25 divided by 0.125 times 10 to the power of minus 3. Now I have to multiply this answer by 4 to get the total distance. Same answer. So 4x would equal 0.025, which is 2.5 centimeters. So you have here is the same answer. So you have two formulas you can use, and both formulas give you the same answer, which is absolutely perfect. It's what you could always hope for.